This is the second theorem, 6.2 theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third line. We'll have to prove this one. Which means, students, in 6.1 theorem, D parallel to BC given, we proved that AD by DB equal to A by EC. But here, AD by DB equal to A by EC given, we have to prove D parallel to BC. This is the Converse theorem of basic proportionality 3. I repeat again, this is the converse of the basic proportionality theorem. Now look, how to solve this one? Let's have a look. Now look, student, this is a diagram of the second theorem 6.2. ABC is a triangle, and DE is a line passes through the point E, or we can say that it is a ray, and one more point is there, F, in the diagram. So we'll have to prove that D parallel to BC. We'll have to prove this one. Let's have a look how to solve this. We'll write here first that given part. Given, this is the 6.2 theorem. Given part, triangle ABC. In triangle ABC, a line L, or you can say that it is ray, intersect AB at D and AC at E, such that AD by DB equal to A by EC. This triangle ABC, a line L, intersect the side AB and AC at the point D and E in such a way that AD by DB and A by EC. This is the given part. Now to prove, we'll prove here that D parallel to BC. We'll have to prove this one, D parallel to BC. Now let's start the proof. Student, this is a rough sketch I have drawn here for proving this 6.2 theorem. Now before starting the proof, if possible, just a thought that DE not parallel to BC. It is just a thought. DE not parallel to BC. So if it is not parallel to BC, then we may take that DF parallel to BC. So let's have a look now. Proof now. If possible, let DE not parallel to BC, then there must be another line through D which is parallel to BC. Let DF parallel to BC. Look, student, if DE not parallel to BC, so there must be one more line, which means DF, which is parallel to BC. So we have taken here DF parallel to BC. This is our initial point. Now look, if DF parallel to BC, so students, according to the basic proportionality theorem we have, so we can write here now AD by, look here, if DF parallel to BC, so we write here AD by DB and AF by FC. AD by DB equal to AF by FC. We'll write here by basic proportionality theorem. Just now we proved that. Basic proportionality theorem. This is the, if DA parallel to BC, look here now, DF parallel to BC, so AD by DB and AF by FC. Now look, after that, what is the given part here in the question? Given part is, look here, given part is AD by DB equal to AE by EF. This is the given part in the question, given part. So this is our equation number 1, this is our equation number 2. Now look after that. Students, in 1 and 2, AD and DB cancel because both are same. So we'll write here now that, we'll write here now from 1 and 2, from 1 and 2. From 1 and 2, students, will write here that AF by EC equal, AE by EC. Now look, sorry, here is AF by FC. AF by FC. We'll add now, this is AF by FC. AF by FC. Now look, we'll add now both the side 1 plus 1. If we add both the side A by EC, then plus 1. Now look, what will happen? We'll take the LCM now. FC. So AF by FC here, and this is EC. A by EC. Now look, student, in the diagram, AF by FC, which means AC. AF by FC, look here, AF by FC, AF by FC, sorry, AF plus FC means AC. We'll write here now AC by FC. Now look here again, A by EC, again AC. So we'll write here now AC by EC. Both the side AC and AC cancel, so remaining part would be 1 by FC equal to 1 by EC. Now look, if I go for the reciprocal here, then FC equal to EC. We'll write here now by reciprocal. Reciprocal. FC equal to EC. Now look, in the diagram, look here now. FC equal to EC. Here also FC equal to EC. But this is possible only. This is possible only, EF coincide. If EF coincide, then it is possible only. FC and EC equal, only possible if EF coincide. So we'll write here now the last line. This is possible. This is possible only when E and F coincide. Hence the last line will say that if these are coincide, student, so if these two are coincide, which means DF and DE are equal, so DE parallel to BC. DE parallel to BC, hence proved. This is the second theorem.